So this time SmartFrac just read this file, and it's going to overwrite that SDL from temp one more time. Okay, so now what SmartFrac created for us was this SDL from template file, and now we're going to look at that. And because it's so huge, SmartFrac is going to change it, is going to make it into include files, one for each of the different symbols that we created. Okay, so there's the dedicated pins, the generic I/O pins, the transceiver banks, the FPGA power pins, and SmartFrac kind of snuck those transceiver pins, the MGT transceiver pins, into that. And then because it saw that there were so many ground pins, it split the ground pins into a set of symbols, and it split the VCC in pins into a set of symbols. And I always like the ground pins to come first, or come last, because that changes the most. So I'm just going to, if I move this up, this is the order that the pins are going to be created in symbols. So it's going to use whatever's in this file to describe some symbols and pins. Then it's going to use this one, this one, this one, and this one. So let's take a peek at what's in here. So we can right click and say include files, edit selected include file. And we can see that it sorted all the pins for us for the dedicated I/O banks. And if we want to fine-tune it, we can go into this file and move pins around and kind of do whatever we want with them. For this demo, we're not going to move these too much. The next one, this is going to be a huge file. So we're going to look at the generic I/O banks, and we'll open that one. And what we're going to see is there's one symbol created for every I/O bank, just like we talked about. So for every I/O bank in the part, there's a symbol created, and we can see that they all look exactly the same. Here's bank 63, here's bank 62. If we go to line 1, it starts at bank 19, and it goes all the way down to bank 98. Okay. Again, so SmartFrac built this for us, and this is the special regular expression that SmartFrac uses to get all of the I/O pins. So this one line here matches all 52 pins for the part. Then it puts a spacer, and it puts the VREF for that bank. And then on the right, it's going to put the power pins for that bank, BCC on19, 1 to 3. Bank 20 is going to look exactly the same. We're going to have the special regular expression for bank 20. We'll put a spacer, the VREF, and then the BCAO pins on the other side. And then we'll come down all the way to banks 72, 74, 76, 77, and 78. 78 is the last normal bank, so he's in the center row of I/O banks. And same as the bank 19 up above. Here's the special regular expression for, or pattern for matching all 52 bidirectional pins for that guy. They go on the left. We put a spacer. We put the VREF pin, and then on the right we put the power pins. So then let's take a peek at the transceiver banks that it creates. So now, just like the generic I/O banks, it splits this up for us. So it puts the receivers on the left. It puts the transceiver receivers on the left. It puts the transceiver transmitters on the right. So these two are going to be even with each other for this bank. It adds a spacer, and then it adds the ref clocks, and then it also adds these MGT pins, the RCal, if they exist. So in bank 220 we have those calibration pins, but in bank 221 we don't, and SmartFrac knew that and took care of it for us. So here's FPGA bank 221, 222. Then it's 225, 226, 227. And then it starts with the 230s and comes all the way down to the last 237. So right now we're just looking at this and we'll run it. What we're going to come back and do is maybe tweak this. So again, PartBuilder built one symbol for every transceiver bank. We could actually probably fit 3 transceivers in a bank easily. So what we can do is we can come back later and play with this. And we'll do that later. And all we would have to do is kind of take these starts of symbols out and end of symbols out, and so this is what we see here is this is a start of symbol, this is an end of symbol, this is the start of the new symbol. So if we wanted to join these guys in a symbol, we would just delete this, and then this set of pins and this set of pins would be in the same symbol, and we'd create a smaller set of symbols. So we'll talk about that later. And then let's look at the power pins. Here's our power pins. You can see it built a special symbol because of the pin group, the symbol map file. It built us a special symbol for the MGT pins, and the right north are on the top, the right upper center are next, the right south and the right lower center are next. And then these are the leftover FPGA power pins that don't match VCC int and ground. So these fit in another symbol. So this include file builds 2 symbols, the FPGA power pins 1 and the MGT power pins. And then this one's going to be really simple. This is the VCC int pins. We'll take a quick look at that. And it's just one line. So it creates a symbol called VCC int pins. It ends the symbol, and then it says you have VCC int 1 to 232. Place them in as many symbols as you need on both sides. So it just distributes these pins into 2. In this case, it'll be 2 symbols. If we had set the symbol pin limit to 250, it would be 1 symbol. So it's smart enough to know how to deal with the symbol pin limit. And then, of course, the ground pins. They'll look exactly the same. We're going to edit the selected include file one more time. And the ground pins. So there's 972 ground pins. And this simple statement tells PartBuilder how to build all the symbols for those grounds.